All right, hopefully you have a sheet in front of you, and we are going to start 7-1 today, and then on Friday you will do 7-2. It's all about rational exponents, radical expressions, square roots, cube roots, simplifying, and so on. Before we get started, and we did this at the first of the year for something, I don't remember what it was, but let's write some perfect squares. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. We're going to be using these so much that I'd like to have them in front of you. We can even put them on the board for a few days just so you kind of get used to things. 8 squared is 64. 9 squared is 81, and we'll go up to 10 squared, which is 100. If you need more than that, we can work on it. I don't think we will. But I also want to look at some perfect cubes. And again, 1 cubed is 1. 2 cubed is 4 times 2, which is 8. 3 cubed is 3 times 9, which is 27. 4 cubed is 64, and 5 cubed is 125. And notice I'm not going to go much further than this because I don't really think we're going to need to get the job done. Fourth power, 1 to the 4th is 1, 2 to the 4th is 16, 3 to the 4th is 81. And that's probably as far as we need to go with those. So why don't you copy those down on your notes, and we can start the worksheet. I've given you a definition basically of what this power means. You're used to seeing something like I've written over here where I say 5 squared equals 25, and you know that 5 squared means 5 times 5. There's 2 5s, which equal 25. When we write something to the 1 over n power, we're taking the root, which we're going backwards. If I say 25 to the 1/2 power, I'm saying that there is a number whose second power is 25, and that answer would be 5. And that definition is just a little bit wordy. Basically, let's just go with root. So all of these are going to be a perfect whatever root we are looking at for today. And then on Friday, you'll go a little bit beyond that. So the square root of 9 is 3 because 3 times 3 is 9. The cube root of 8 is 2. I'm going to come over here because basically I'm saying there's 3 things multiplied together, and when I multiply them, I'm going to get 8. And so those 3 things would be 2. When we incorporate negatives into the problem, you're basically, we can add 1 to the 5th over here to be 1, because 1 to any power is going to give us 1. Negative 1 to any odd root is going to be negative 1. And we're going to learn later on that you can't take an even root of a negative. So all of our negatives will be to an odd root, 3rd root, 5th root, and so on. Then when we do more than just have a 1/3, 1/2, 1/4, and so on, when we actually put a power on top, so this number is the power, and this number is the root. And you can do these in any order, but I highly recommend that you do the root first and then the power. So we're back up to the problem up above. The cube root of 8 is 2, and 2 squared is 4. So I simplified what was in the parenthesis first. So parenthesis, then exponents, the PE and PEMDAS. Likewise over here, I'm going to take the square root of 9 first, and then I'm going to cube it. So the square root of 9 is 3 cubed, and that's 27. You see what I'm doing on each one of these? It's hard to see this little mark in front, but this is actually negative 2/3 power. Let's talk about what a negative exponent does. A negative exponent does not make the base negative. It takes and makes the reciprocal. So we can think of this as 64 over 1. So the first thing I'm going to do is write this as 1 over 64. That takes care of the negative. Then, like we did before, I'm going to take that to the 1/3 power. I'm going to do the root first, and then I'm going to square it. So there's something over here that cubed gives me 64, and so that's the 4. So I have 1/4 squared, which is 1/16. There. Okay? Now, writing these fractional exponents as radicals, and that's the way you used to see them. When we take the problems that we had up above, I'm really just, and some of your homework is not asking you to find anything, it's just asking you to rewrite it. So that's all we're going to do with this next set of problems. This is the 1/2 power, which is square root, so I'm rewriting this as the square root of 9. And the interesting thing about square root is you don't have to put the 2 there. If there's nothing in there, the index is understood to be 2. Now, if I want to take the cube root of something, I actually have to put the 3 in, kind of, it's tucked in the V of the radical. So there's the root, and there's the base right there. And then on this last problem, same thing. We're going to put 5 outside and -1 inside. So we're not really doing anything. We're just showing that we can write them. And then on this next set, we will take 8, and we'll take the cube root of that. So that takes care of the root, and then the power goes outside. For this one, we'll take the square root of 9. Notice that I'm not going to write a 2 there. It's not wrong to do that, to remind yourself what root it is. You just don't have to. And then the power on the outside is 3. And then on our last one, we will take, I'm still going to deal with the negative. So I'm going to write the 64 over 1 as 1 over 64. And we're going to take the cube root of all of that. So I'm going to make it nice and tall to get on the numerator and denominator. And then the power last. There's the 2 on the outside, the 3 on the outside. Okay. Simplifying roots of perfect powers. What I mean by that is that everything inside this radical can be written as a cube. Everything inside this radical can be written as a perfect square. So for this problem, first thing I'm going to do is take the cube root of -8 times the cube root of x to the 6th and the cube root of y to the 9th. And it might make more sense to you with the x's to write those as fractional exponents. But the cube root of -8 is -2. So we're going to take this term, or factor by factor. They're not really terms. And then x to the 6th is to the 1/3 power. And y to the 9th is to the 1/3 power as well. And if you remember when we first worked with exponents earlier this year, when you take a power to a higher power, you multiply. So we've got the -2 out front, x to the 6 over 3, which is 2, and y to the 9 over 3, which is 3. And there's your answer for the first problem. Coming over here, let's rewrite this one. So I've got the square root of 25. I have a to the 20th to the 1/2 power, and b to the 8th to the 1/2 power. So the square root of 25 is 5, so I've got my coefficient. Now, here is something in the definition. If you have the nth root to something to the nth power, that's something. So a to the n, the nth root of that is a. But notice when n is even, square roots, fourth roots, you actually get plus or minus unless it's understood that this is a positive value. So I'm not going to make you put the plus or minus, but I would be a bad teacher to not include it in my lesson. So we're going to assume that all our bases, all our a's, b's, x's, and y's are positive, so we don't have to put the plus or minus. So to finish this up, 20 times 1/2 is 10, and 8 times 1/2 is 4. Okay? So you have some homework problems to do. You've got 20 through 140, DB5. If you need to make up the test from last week, that would be Luke and Ajayla. Please see Miss Prine for a day and time, and she will schedule it for you. I will see you all on Tuesday.